So I'm going to be covering SSL pinning, which, um, for anyone who is unaware of what that is, has never heard those words before. We went through the whole thing a while back where we set up um, the Burp Suite certificate on our emulator. We were able to do stuff like um, get the request and edit it and make changes to it. So we were able to do that because of that certificate that we got from Burp, and that works with applications as well. So like if we go to Twitch and we like go to the login page of Twitch, we're seeing requests to the Twitch APIs. We could like intercept those requests and we could edit them and play with them and do stuff like that. But if an app has SSL pinning enabled, then it would not recognize that certificate that we installed from Burp Suite, and then it would reject everything that we tried to do when we're proxying it through Burp. So we have to find a way to bypass that pinning mechanism. Twitch does not have SSL pinning enabled. At least the APIs that have attempted to talk to do not seem to have SSL pinning enabled. But if we look at the Twitter app, which I also have installed on this device, I open Twitter and say I want to log into Twitter. It says, oops, something went wrong, please try again. And it just kicks me out and sends me back to this page. And I can just keep clicking login, try to get to the login page, and it just won't work. It just kicks me out and says, nope, you're not allowed to do that. I can try to create an account, same thing. Oops, something went wrong, please try again later. That's because Twitter has SSL pinning enabled. So we are going to have to do something to bypass that SSL pinning mechanism in the Twitter app so that we can actually use the Twitter app and intercept all of those requests through Burp and maybe mess with requests and see what it's doing. Frida is a free open source technology. It's got tons of community support. There's pretty good documentation on it. And there's all kinds of like scriptable and different like things you can do with it to interact with mobile apps in both Android and iOS. But one of the most popular functions you can do with Frida is bypassing SSL pinning. All of these tools we're going to use are that are part of Frida are Python based, so we can actually install them with pip, which is just like a little package manager kind of type thing that works on Python libraries and things like that. But we just want to run pip install Frida. Pip install objection, which is another tool that kind of works pretty closely and in conjunction with Frida. And our last one we need to run is pip install Frida tools. There's one other thing we need to install, and that is the Frida server, which will actually be installed on our device, on our emulator. So on github.com/Frida/Frida/releases. And there are a bunch of things listed here, different kinds of Frida things that can be installed depending on what you're trying to do. The one that we are concerned with is going to be Frida server. And you'll notice that there are a bunch of different ones that say Frida server, and they have some stuff at the end of it. So we have to figure out which one we actually need. And that's going to be dependent on the architecture of the device you're working with. There is a command that you can run with ADB that will tell you, our trusty friend ADB. We just run ADB shell git prop ro.product.cpu.abi, and that will tell you the architecture of your device, And in this case, this is an x86 architecture. Back when we built this device, when we were going through the Android Studio walkthrough to set up the emulator, we chose a system image that was x86. And if we look in like the device manager of Android Studio, I'm sure we could find that information somewhere. But just for any future reference, no matter what kind of device you're looking for, you should be able to run this command, and that will tell you what kind of architecture that device is. github.com/Frida/releases, that should by default send you to the latest version, which in this case is 15.1.17. So we're going to go to Frida server 15.1.17-Android-x86. We'll click that, and that will download that. Here is that file, and I need to extract it because it came in this .xz compressed format. So I'm going to run xz-d on that file. I'm going to use the mv for move to rename it, and I'm just going to change it to Frida server without any of the other stuff at the end of it. We are once again going to use ADB, and we are going to push that Frida server file to data/local/tmp. So there we go. Push the file. It is now on our device, but now we need to be able to execute that file. So we need to use chmod to change the permissions. So we are going to use shell to run a chmod plus x. When we run ADB shell, we can like drop into a shell within like the file structure, and we can like run commands and move around the files of the device and do stuff. But if there is just like one specific command you need to run on it in the shell, you can just run ADB shell and then put that command in quotes, and it's just like a one-liner. That way you don't have to drop into a shell, run that command, and then back out of the shell and continue what you're doing. You can just, in one command, run that thing you need to do in the shell without having to go into the shell and then back out. So it's just like a little convenience thing. But we're going to run that chmod command. So now that Frida server file should be executable. And now we're going to actually execute it. Once again, we're going to use ADB shell data local TMP to that Frida server. So we're going to run that file since it's executable now, and we're going to put an ampersand at the end, which basically just means background that process, so we don't have to like keep this terminal open and running as long as that that program is running. We can just background it and it'll just keep going. This is just going to be kind of like a sanity check to make sure we've done everything so far, and hopefully it doesn't break and not work and tell me that I did things wrong. But if we run this, it should just spit out a list of all the processes running on the device, and that will just tell us that the Frida server is running properly. Yep, there we go. Okay, so these are all of the processes that are currently running on our emulator right here. And because we were able to get that information by running this Frida-PS, that means that the Frida server is running and properly working. So now we have Frida working, so now we need to add the part where we actually bypass the SSL pinning. And to do this, we're going to use something from what's called the Frida code share, which is a huge repository of mostly community built modules and different things that you can do with Frida. All of these things are just modules that people from the community have built and uploaded, and they're free to use. You can download them and use them, and it's awesome. And there are a bunch of different ones that people have built in order to do the SSL pinning bypass. So there are a lot to choose from. This one is actually the one that I'm going to use. I've just used it before, and it's pretty simple. It's very straightforward and seems to work pretty well. So this is the one that I'm going to use. There are plenty of other similar things out there in the Frida code share. We need to have the name of our binary. We can run adb shell and look at the data directory, which we talked about a while before, about looking at the file system of the Android device. com.twitter.android. So that is the name of the package for the Twitter Android app. We need to replace this with the name of our binary, which is com.twitter.android. Once again, it's Frida -- code share. The name of the module from the code share that we're going to use -f, and then the name of our package for that app that we want to bypass the SSL pinning for. We run that. Did it work? It might not have worked. I need to add another flag. I thought there was another flag I needed. Okay, there we go. The -u flag did it. That began the execution of the Twitter app. So you see that it launched the Twitter app, but it's stuck on this screen with the bird logo, and it's not going any farther than that. So we are going to run %resume, and that should let it continue execution. Now that we have this running, we have bypassed SSL pinning, and it should work. So because I forgot to point it out before, earlier when we tried to run the Twitter app through burp, we were getting these errors, which I don't know if you can read that, but it says the client failed to negotiate a TLS connection to api.twitter.com. So we were getting a bunch of these TLS errors, which means that certificate was not being recognized, and that SSL pinning was getting in the way. Now we have Frida running and have that SSL pinning bypass library working. So now when we click log in, now it goes to the login page. We're not getting that, oops, something was wrong, please try again later. We're not getting that error anymore, and we're also no longer getting any of these TLS connection errors. Everything seems to be working fine. We're able to intercept these requests to the twitter.com API, and we could intercept that and edit that and do everything that we did before when we were working with Twitch. And I could put in my Twitter account and hit next, and if I wanted to, I could put in my Twitter password, which I will not do right now on stream, and I could log into Twitter, and I could browse my Twitter feed and go nuts and just be intercepting the request with Burp Suite the entire time, and it's no problem, even though they have SSL pinning enabled, and which is specifically designed to not let me do this. One thing to note is because we had to install this Frida server on the device itself and execute it on the device, because you have to do that part, you do have to have a rooted device in order to do this.